Alright, going to 26 through 36 here. In number 26, a ball is thrown vertically upward. What happens to the ball's velocity while it is in the air? Well, as the ball goes upward, it will slow down until it reaches a zero at the peak of its motion. And at that point, it will begin to accelerate downward, so it'll speed up on the way down. Part B, what is the velocity when it reaches a maximum altitude? When it reaches the top, it will be stopping just ever so momentarily, but it will stop. What is the acceleration for all the next three? The acceleration will remain constant at 9.81 meters per square second. All things have an acceleration of gravity of 9.81 here on Earth, as long as we are ignoring air resistance, which we are doing. In number 28, a juggler throws a bowling pin into the air with initial velocity. Another juggler drops one at the same instant. Compare the accelerations of the pins as they're in the air. The accelerations will be identical. Now, the ball thrown up will certainly have more time to gain speed as it falls, but depending on how fast the other one isn't being dropped, it's just being dropped, so it's kind of a VI of 0. So the one that's thrown up will hit the ground at a higher speed only because it will be in the air falling from a greater height because it's thrown upwards. But the question is asking about acceleration. Number 30. A worker drops a wrench from the top of a tower 80 meters tall. What is the velocity when it strikes the ground? I look at this one as sort of a two-part question. I first use, not that one, I first use this one. I put my 80 meters in as a negative 80 because it's falling 80 meters. I divide by half of the acceleration of gravity, 9.81, and then I get my t squared. I square root to get t. So find the time using this equation. Take that time, report it here, and you can get your velocity. You could do it in two steps, and that's the way I like to think about doing it, but in reality, you could come to this equation right here. You have your acceleration of gravity, you have your height, you have your VI, which is 0. You can find the final velocity in one step following that equation. Two different ways you can do it. And then to number 26. Number 26, you have two students throwing one ball each. One is thrown upwards with a velocity of 14.7. The other is thrown downward with a velocity of 14.7. So what is the difference in the time they spend in the air? What's the velocity of each one as they strike the ground? How far apart are they 8.8 seconds after they are thrown? Two individual items moving at individual speeds in individual directions. Do them separately. Okay. Part A, what is the difference in time each one spends in the air? So let's solve for the time of each one as it goes in the air. Because we don't have V final, this is going to get tricky. So what I would do is I would actually solve for B first. What is the final velocity of each one? Let's first think about the one that is dropped. VI is 0. Or no, VI is positive 14.7. VI is positive 14.7. 2 times that acceleration, 9.81, times 19.6 meters. Now, make that a negative 19.6 with a negative acceleration. You'll find the V final. You can do the same procedure with the one that is thrown upwards. V final is now positive 14.7. It was negative 14.7 before. Take that with also the same acceleration of negative 9.81, and believe it or not, the displacement of this ball will also be 19.6. Okay? It's interesting how this one will come out for you. Then, so that's your final velocity of each ball. Then you say, what is the difference in time that they spend in the air? Well, now that you know the V finals, you can take both the V finals and you can use them to find time. So if I have V initial and V final and acceleration, I can find time. And then how far apart are they at 8 seconds? Well, now you can do V final, V initial time and as 0.8 and find displacement here. That would be the way I'd do it. Or you could do the same thing here, 0.8, 0.8, A, and VI, and find displacement here. So displacement with VI and T. That's a lot. It's a big question. A lot of things to think about. The big deal is think of each one individually as you do it. Okay? Enjoy. Good luck.